Hello beautiful people and welcome. In today's video we are continuing our conversation about functions and the inverse of functions, and in this video we're going to be focusing on the composition of functions to verify inverses. As always, disclaimer time, I am human. If I make a mistake, let me know where the mistake occurs so that way we both can learn from my mistake. Alright, so composition of functions is a function inside of a function. There are two notations for it. We have this notation and then we have this notation. We're going to read it the same way. F of g of x and then f of g of x. So this is not a O, so we are not saying fog x. No. We're saying f of g of x. And the key when dealing with composition of functions, you're going to work inside out. So whatever's inside, whatever's closest to x, that function gets done first, and then we work towards the outside. So let's go ahead and just jump right into examples. But before we do, let's go ahead and define domain and range. Because this is asking us to give f of x and g of x, given f of x and g of x, find each function and state its domain. So just a reminder, domain are our inputs, and that is our x values. Range is our outputs, and that is our y values. Easiest way to remember is think alphabet. If you sing the alphabet, the letter D comes before R, and then the letter X is before Y. So that way the ones that come first are together, and then the ones that are later on in the alphabet are together as well. All right, let's go ahead and do that. We're just focusing on evaluating compositions for these two examples. So here are our two functions. We have f of x is equal to 3 minus x, and then our second one is g of x is equal to x divided by x plus 1. And we want to evaluate f of g of x. So this is the same thing as saying f of g of x. So we want to work inside out. Let's go ahead and I'm going to switch to pen so you can see it. So this is f of g of x, and we want to plug in our function. So what that means is we're going to take g of x first, and we're going to plug that into, we're going to take that first and we're going to plug it into my function of f. So how does that look like? So we want to do g of x into f of x. Okay, so g of x is x divided by x plus 1. This is going instead of x in our f of x equation. So let me actually write this out a different way. So you know how we have f of x is equal to 3 minus x? Well, instead of this x, what we're going to put is we're going to put our g of x in it. Because we are not evaluating f, the function, in terms of x. We are evaluating the function f in terms of g of x. So g of x, this x gets erased, and what we're putting inside that x is our x over x minus x plus 1. That's what's happening. We're taking our g and we're putting it into our f. We're taking our g and putting it into our f. And so at this point, we're going to see if we can simplify any of it. The only thing I can think of is combining like terms, and in order to do that, we need to make this into a fraction. So I'm going to say I have 3 times x plus 1, and I have x plus 1 on the denominator, minus x plus 1. Now that I have common denominators, I can go ahead and subtract these. So I'm going to say 3x plus 1 minus x all over x plus 1. And so what do we have here? We have 2x plus 1 all over x plus 1. Now it's also asking us what is your domain, and domain is all of our possible x values. So what can x be? So when you're solving for domain and range, you're going to ask yourselves, what can it be? So what can x be? Well, can x be 5? Sure. Can x be 1? Sure. What can x not be? And in this case, since we have x in the denominator, x cannot be 1 because then we get 0 in our denominator, and 0 does not exist in the denominator. So x cannot be 1, but everything, negative 1. But x can be everything else. So we're saying in our domain, x cannot be negative 1. All right, let's do another example. This time we're taking g of f of x. So again, g of f of x. So what that means is I'm taking my f of x and I'm putting it into the g function. So what is the g function? The g function is x divided by x plus 1. That is what my g function is. So anytime I see x, now I am putting in whatever my f function is. And that is 3 minus x. And then what is my x again? I no longer have x. I have 3 minus x, whatever g of x is. F of x, whatever f of x is, it replaces the x's in the g of x function. So, okay, so what do we have here? Please do not start crossing this out. That is different. Combine like terms first. I have 3 minus x all over 3 minus x plus 1, so that is minus x plus 4. And there's nothing else really to simplify further. We just need to know what x cannot be and what x can be for our domain. So for our domain, can x be all real numbers, or does x have a limitation? And x does have a limitation. X cannot be 4 because if I plug in 4, negative 4 plus 4 is 0. I cannot have 0 in the denominator. If I have 0 in the denominator, the world explodes. It doesn't exist. The world explodes. All right, so this was just a quick review. Let's go ahead and verify some inverses. So when verifying inverses, the question is going to be, hey, is f of x and g of x inverses? So you have literally a 50-50 shot of getting it right, because you can either say yes, they are inverses, or no, they are not inverses. But what we are working on is the work behind those two answers to see if in fact they are inverses or in fact they're not. So how we're going to figure that out, we're going to say f of g of x must be equal to x and g of f of x must be equal to x. Basically, we're solving two composition of functions, and they both have to simplify to x. If they simplify to x, and they both have to, simplify. That means, yes, they are functions. If one of them is not simplified to x, then you do not have to do the other one. You only do one because it already fails. If one doesn't work, then stop. But if one does work, you have to test the other one. Both of them have to work. So let's go ahead and try this out. Verify algebraically if f and g are inverse. Well, let's go ahead and try it. The first thing we're going to do is f of g of x. And so what is my f function? That is x minus 7 divided by 2. But I do not have x. What do I have? I have my g, which is 2x plus 7. I'm going to simplify that. So I'm going to write it just a little bit better so you can see. This is what I have in my numerator. This is what I have in my denominator. Immediately I see a plus 7 minus 7, so I'm going to simplify that. That goes away. I have 2x divided by 2. 2's get crossed out, so f of g of x is in fact equal to x. So that is step 1. So now we need to check the other one. You cannot assume anything. You have to check both. So I have g of f of x. Again, so now I'm writing what g is. G is, oh, I don't know why I did that, but g is not a fraction. I have 2x plus 7 And I'm kind of writing it to leave some space because I know I don't have an x. What do I have? I have my f, which is x minus 7 divided by 2. So here I see that I have a 2 on the top, 2 on the bottom. That goes away. I have x minus 7 plus 7. Minus 7 plus 7, those goes away. So what am I left with? I'm left with x. So I have g of f of x also equal to x. So because both of them are equal to x, my answer is yes, inverses. If you give me an answer without showing your work for the composition of functions, you will get it wrong. I guarantee I will not accept an answer without any works. No work, no credit. Let's do more examples. Again, are they inverses? Let's find out. F of g of x is equal to, what is f? F is the cube root of x plus 2, that is f. But instead of writing x, what am I writing? I'm placing g of x, which is x minus 2 cubed, into the x placement. Now here I have something that's cubed, and I have a cube root, so those go away. So I'm left with x minus 2 plus 2. Minus 2 plus 2, they go away, so I am left with x. I'm doing a little happy dance because so far things are working out. Let's check if the other one works as well. So now I am doing g of f of x. So I'm writing out what g is, and then I'm going to replace x with whatever f of x is. Again, I did a line. I don't know why I keep doing lines like that. So I have x minus 2. All of that is cubed. I don't have x because I have f of x. So I'm going to take whatever f of x is, and this is all of this. So I'm going to actually move my minus 2 a little closer here. All of this is my x, which is root 3 x plus 2. And all of that's being cubed. So then look what I have. I have cube root of x plus 2 minus 2, and all of that is cubed. I just wanted to rewrite it so we can see it better. Plus 2 minus 2 goes away. What am I left with? I'm left with cube root of x cubed. Because those are opposites, they undo each other. What am I left with? I'm left with g of f of x is equal to x. Both of them are equal to x. So my answer is yes, inverses. Let's do one more example for the composition of functions. This time I have an h, I don't have a g. It doesn't matter what letter they give you. So now instead of saying f of g, I have f of h of x. So again, I'm writing whatever I have. I have 3 divided by x plus 1 plus 2. But I don't have x. What do I have? I have all of this mess. So I'm going to put it in brackets because it is a little bit on the bigger side. So I have 4 divided by x plus 1 minus 3. So let me simplify that a little bit. So I have 3 divided by 4 divided by x plus 1 minus 3 plus 1. And then I have my plus 2 here. What I'm seeing here is I have a minus 3 plus 1. So that means I have minus 2 plus 2. I can't really cancel these out because this is dividing by a negative 2. This is adding 2, so two different things. So what I'm going to do is I'm going to start using common denominators to combine this. So I know I have a minus 2 here. I'm going to multiply this top and bottom by x plus 1 and see if I can combine it. I'm going to put an arrow because I'm starting to run out of room, but that's okay. So I have 3 divided by, I have 4 minus 2x minus 2 all over x plus 1, and I'm still adding 2 on this side. I'm going to subtract 2, so I have 3 divided by negative 2x. All right, sorry guys, I don't know if you noticed that, but I did have to pause the video just for a quick second. Someone walked into my room. All right, let's go ahead and continue. Things are starting to be a little bit complicated. So my guess is it's not going to work, but maybe it will. Maybe. My guess is it won't, just because it's usually not this complicated. to get to x if they are inverses of each other. So I have negative 2x, and then these simplify. 4 minus 2 is 2, so positive 2, divided by x plus 1 plus 2. Again, things are just being more and more complicated. So I have 3, negative 2x plus 2 divided by x plus 1. I still have this plus 2. Still not working out. Next, I would have to do common denominators. So if I do common denominators, things are just getting messier and messier. Do you guys see that? It should not be getting this messy. So we have two options. We can say, no, they are not inverses because it shouldn't be this complicated. Or we can say, we're going to erase all of this and try again. I'm going to say these are not inverses of each other. It just keeps getting more complicated and complicated. That's the opposite of what inverses are. Inverses, we're just going to simplify to x. So I'm going to say, no, not inverses. Because it's not simplifying to x. Again, you guys, if you want to continue this and it does equal to x, go ahead and message me and we can update this video. But again, I'm going with my gut here because it's getting more and more complicated. It's not simplifying. It's not, I mean, it's not going to work. But so we're saying not inverses. Typically, if they are inverses, you're going to see something like this where things just cross out. Things are pretty. We're going to have pretty things canceling out. And it's going to be a lot easier than something like this. If it turns out to be this big of a mess, they're not inverses. All right, beautiful people, that wraps up this video. I hope you enjoyed it. And again, if it's asking you to make sure that these two are inverses or not inverses, you have to use composition of functions. Yes, there are other ways to figure out if they are inverses or if they are not inverses, but specifically for checking, you must use composition of functions. If on an exam or a quiz you don't use composition of functions, you will be marked incorrect. You will not be getting your points. You will not be getting credit. All right, beautiful people, thank you for watching, and I will see you in my next video. Bye.